All right, so this should be 13.4 notes here. Don't know why that didn't save. Anyways, chapter 13.4. Now we're adding on to this idea of permutations. We now have combinations. So a little reminder of factorial. So we have factorial. Remember, this is a little exclamation with at the end of math, we'll call it factorial, and it means 9 factorial is 9, 8, 7, 6, 5, 4, 3, 2, 1. And again, we can cancel those out, simplify life. Like on this one here, that's fully multiplied out, but the way I would do 8 factorial and 5 factorial is I'd go 8, 7, 6, and then 5 factorial over 5 factorial, because we know those are going to be the same, and you can cancel out from there. Alright, so multiplication, we've done a couple of problems like this. This one is not all that helpful because the biggest one is a 3, so that means our 14, we're now going to have to write 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, and then 3 factorial over 3 factorial times 2 factorial. So the 3 factorials cancel out. 2 factorial is now just 2 times 1. 2 cancels with that 4, leaving us with the 2 there. And then 1 is left. And so then we can multiply 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, and 2 to get our answer, which ends up being a really big number. So 7.26 times 10 to the 9th power. Okay, so crazy big. That's why a lot of these won't fully expect things to be always multiplied out. All right, so a permutation, like we've talked about before, is an arrangement of items in a certain order. So order matters, right? So A, B, C is different than B, A, C. Order matters on that. Those are two distinct arrangements. So for a permutation, we had this formula which you've seen before, the n factorial over the n minus r. N, remember, was how many we're choosing from. R was how many we're picking. So same thing over here. N is our total amount. R is how many we're choosing. So this is for a combination. So we have NCR now. And notice in NCR there's this extra R factorial because order does not matter. So that example of ABC and BAC, for a permutation that would count as 2 arrangements. For a combination that only counts as 1. Okay, because order matters. We change that again. Let's say it's CAB. That means now for permutations, those are 3, but a combination it is still 1. So a significant difference with that extra division there. All right, so let's a little practice evaluating expression. All right, so we have our 7 factorial. And remember, it is 7 minus 3 factorial. And then for combination, we have that extra 3 factorial. So 7 factorial, let's go 7 times 6, not 5. 7 times 6 times 5 times 4 factorial. Because the bottom here, we have a 4 factorial. That cancels out. And then I have 3 factorial, which is 3 times 2 times 1. 3 and 2 is 6. So then really we're just left with 7 times 5, which is 35. All right, and then 9 combination 4, so 9 choose 4. So 9 factorial on top. 9 minus 4 factorial times another 4 factorial. That gives us 9, 8, 7, 6, 5, all over 5 factorial. So that cancels out. And then I'm left with 4, 3, 2, 1. 3 and 2 is that 6. 4 goes in the 8. Twice there. 1 doesn't matter. So we have 9 times 2 times 7, which gives us 126. And again, if you don't want to do the canceling like I was with the 4, 3, and 2, you can just multiply it all out and then divide by that amount as well. So 13C8 here. So one more, let's go 3 factorial. We get 13 minus 8 factorial, and then 8 factorial. So I get 13 times 12 times 11 times 10 times 9 times 8 factorial. And now generally we stop with whatever that one is. 13 minus 8 is 5 factorial. But in this case, 13 minus 8 ends up being the smaller of the two. So I stop at the bigger of the two because it cancels out the most for me. Now that 5 factorial becomes 5 times 4 times 3 times 2 times 1. So let's go that 5 and 2 is 10. 4 and 3 is 12. So then we're left with 13 times 11 times 9, which gives us 1,287. All right, so your English teacher has asked you to select 3 novels from a list of 10 to read as an independent project. In how many ways can you choose which books to read? So then big question comes up, does order matter? So on this, you have to read 3 novels, but the order you read them in doesn't matter as long as you read your 3, correct? So this would be a combination. So we have 10C3. And so we have 10 factorial over 10 minus 3 factorial times 3 factorial again. So 10 times 9 times 8 times 7, all over 7 factorial. That cancels out, and then I have 3 times 2 times 1. 3 goes in the 9 3 times, 2 goes in the 8 4 times. So 10 times 3 times 4 is 120 different ways you can choose 3 books. All right, so standard deck of 52 playing cards is listed to the right there, right? So we have spades, clubs, diamonds, and then hearts, and then ace through king in each of those. If the order in which the cards are dealt is not important, how many different 5-card hands are possible, right? Because you can take the cards, put them in any order you want once they're in your hand, so it doesn't matter. It just matters what cards you get. Okay, so how much are we choosing from? What's our N? We have 52 of those. Order does not matter, so it's a combination. And we want to choose 5 cards, or we're going to be dealt 5 cards, so 52C5. So we get 52 factorial over 52 minus 5 factorial and 5 factorial. All right, so we get 52 factorial over 47 factorial and then 5 factorial. So depending on directions, you could potentially leave it at that, but I think it's interesting to see what the final number is on this one. So 52 times 51 times 50 times 49 times 48 times 47 factorial, and then 5 times 4 times 3 times 2 times 1. So the 47 factorials cancel out. Okay, and then doing this the other way, multiply everything out. Then so 52 times 51 times 50 times 49 times 48 is 311,875,200. And then 5 times 4 times 3 times 2 times 1 is 120. Then we divide those, and that comes out to 2,598,960. And not that I condone this as an educator, but if you were someone who played poker with your family for funsies, in a 5-card hand, which is kind of a basic version of this, there are 2,598,960 different possible hands you could get. Kind of crazy. All right, so with combinations, sometimes you add and sometimes you multiply is based on the wording in the problem, so we have to pay attention to that. So a restaurant serves omelets that can be ordered with any of the ingredients shown. Suppose you want exactly 2 vegetarian ingredients and 1 meat ingredient in your omelet. How many different types of omelets can you order? All right, so on this one, you got to think of it as you're making 2 different choices. You're going to choose 2 vegetarian and then 1 meat ingredient. So we need to decide these separately. So for the vegetarian, if we look over here, we have 6. So we have 6 that we can choose from, and we're going to choose 2. And then right? We're going to multiply 1 meat ingredient. So we have 4, and we're choosing 1. So we get 6 factorial over 6 minus 2 factorial, and then 2 factorial. And here we get 4 factorial over 4 minus 1 factorial, and then 1 factorial. So 6 times 5 times 4 factorial, because we get 4 factorial there. And then 2 factorial is 2 times 1. 4 cancels out. 2 will cancel with the 6, so we get 3. So I have 3 times 5 here, which is 15. Then the second one, we get 4 factorial 4 times 3 factorial. And 4 minus 1 is 3 factorial. And then 1 factorial is just 1, so we're left with 4 there. 15 times 4 is 60. So there's 60 different types of omelets you could order. All right, and then in this one, the restaurant serves omelets that can be ordered with any ingredients shown. Suppose you can afford at most 3 ingredients in your omelet. How many different types of omelets can you order? So in this one, you need to pause and think about what's being asked. So at most 3. So that means you can have a couple different options, right? So we can have an omelet with 0 ingredients. So let's look at our total, right? So we said there was 6 vegetarian, 4 meat. And now we're not breaking up like the last one. We just have 10 ingredients total. So we have 10 ingredients, and we're going to choose 0. And that one should be fairly simple, but we'll show you the math there. But there's only one way to have no ingredients. It's just one way. Now, we can have 0 ingredients, or we can have 1 ingredient. So or is going to be an addition. So we still have 10 we're going to choose from, and we're only going to choose 1. Or, so we're going to add again. We have 10 ingredients, and we can choose 2. Or we can have 10 ingredients, and we're going to choose 3 of them. Okay, so 10C0, so 10 factorial over 10 factorial minus 0, and then 0 factorial. So then 10 factorial, I'm going to leave, because 10 minus 0 is 10. And then remember, definition 0 factorial is just 1. So 10 factorial over 10 factorial gives us 1. Plus, now we have 10 factorial over 10 minus 1 factorial and 1 factorial. So I'm going to go 10 times 9 factorial. 10 minus 1 is 9. Those will drop out. 1 factorial is just 1. So you get 10 ways to do that one. And then we have 10 factorial over 10 minus 2. And then 2 factorial there. And we get 10 factorial over 8 factorial times 2. And I should have done 10 times 9 times 8 factorial. That drops out. And 2 factorial is just 2 times 1. 2 goes into 10 5 times, so we get 5 times 9, which is 45. And then our last one, 10 factorial over 10 minus 3 factorial times 3 factorial. So you get 10 times 9 times 8 times 7 factorial, because 10 minus 3 is going to be our 7 factorial. That's going to drop out. 3 times 2 times 1. 3 goes into 9 3 times. 2 goes into 8 4 times. And so we get 120 there. And we're going to add those up because we had OR on all of those things. Okay, so then 1 plus 10 is 11, plus 45 is 56, plus 120 is 176 different omelet combinations. All right, and then your homework, man, that data is way wrong. Weird things that don't save for you anyways. So it's going to be a combination worksheet. So what we're actually going to start with is this idea of determining whether it's a combination or permutation. I think that's important initially. We'll come back and practice some of the mathematics of it, but initially want to give you the big picture of combination and then go back to, hey, can you identify a permutation or combination?